last class when we met, we've learned something totally bizarre and new. We learned about this thing called a linked list. A linked list is an approach to working with data, similar to what we've done with arrays, but we can have a whole conversation about which one is better than the other. An array is simpler and easier to use. A linked list only uses the memory I need to do. So if this was a debate class, if you picked a side, could you defend it? Why one is better than the other? So we're going to keep both of these ideas in mind, and we're going to build upon both of them as we move forward in the class. Okay. Today we're going to talk about something called stacks. Next Thursday, we'll talk about something called queues. Right? So today and Tuesday, we'll be doing stacks. But what's the idea of a stack? Well, if you go back to CPS 121, you remember you had a term called LIFO. And a stack is something that uses this term called LIFO. LIFO is last one in. Uh-oh. Did I record? Am I recording? Yes, I am. Thank you. Yeah, it uses LIFO. Last in, first out. Okay. Now, what is all this LIFO? Sitting here yesterday, and I'm going through all kind of examples. If you go into a grocery store, you know how they put something on the shelf and they push everything else back, and then when you get ready to take one, you pull the front one out. Okay. Better example is a pile of plates. When you're drying dishes and you're putting them back in the cabinet, you dry it, put it in, dry it, and you keep putting one on top of the other. And then when you get ready to use one, you just take one off the top. A couple of you may know what I mean by a PEZ machine. Those little things where the head tilts back. And so the last one you put in is going to be the first one out. I like to think of filling my gun clip, the last bullet I put in is going to be the first one out. So lots of different examples of what the stack idea is. Now, we already have our two classes that we've created, the array class, the static one, and we have the linked list one, the dynamic one. It's the one that can grow. Well, in order to use and work with stacks, we're going to build on either one of these. We'll have an option. But when I'm working with the stack, two new operations have to come into play. One is called push and one is called pop. And if you think about, I go back to the PEZ, you pushed it down, and when you're ready, you can pop one off the top. So if I started doing something like a stack in my mind, and I say push 5, 5 is going to go here. Okay. When I push 11, 5 moves down. So now I would have 11 on top and 5 moving down. Then if I said pop, 11 would come off the top and I would only have 5 left. And if I say push 14, the 5 moves down and now the 14 is on top. So I have this whole concept of how I'm going to build this. Now, I'm going to do that same thing again, but this time when I push, it's going to dribble all the way to the bottom. And I'll show you in a minute why I want. So push 5 goes to here. Push 11 is going to go there. Pop is going to take the one off the top. So that would take 11 off. Push would put it back on. Now, the reason I do that is we're going to think of this idea in terms of an array. And in order to think of this as an array, I'm going to take that stack and I'm going to push it over so that it falls down. And when it falls down, I now have my array. So when I get ready and push 5, I'm going to put the 5 in the first location. When I push 11, I'm going to put 11 at this location. Okay, and then I can keep going. If I want to pop, I'm going to pop the 11 off. It's off. And when I push again, I'm going to push the 14. So in this world of working with an array, and as I keep doing it, I had the 5, and then I had the 5 and the 11, and then I just had the 5, and then I added the 14. I start to get something that looks like this. When I'm working with an array, I'm going to, and as the example went through, add to the end. So when I push, it's going to add to the end of the array. And when I pop, it's going to pop from the end. Now, when I was creating this, I kind of had a choice. I could have either added to the beginning and popped from the beginning, or I could have added to the end and popped to the end. The way I did it was this guy. Well, what if I would have decided to put him at the beginning? So what if I would have said, okay, I put in 5. Now I want to put in 11. What would I have to do if I'm adding to the beginning? Well, make this 11, make this 5. I'd have to be shifting a lot. So I think in this case, again, if I pop, I'm going to have to be shifting everything to the left. So working at the end of an array is going to make it kind of nice. Now, I can do the same thing, have a pop and a push, working with linked list. I'm thinking of this pile of paper plates or pile of plates. And what would I say the one here is? It's the one that's on top, So let's go back to, we called this head, and it pointed to the first one. And if I get ready and push 5, I now have head would go to the node 5. 5 is going to point to null. Where would you like to put the 11? We have 2 choices. I can add it to the beginning, or I can add it to the end. Where would you like to put it? Think it through.
So for this one, wouldn't it not really matter because it's just as easy to do it to either?
Okay. I hear it just as easy to do it to either. When I came back over here to this array, if I wanted to add another one, right? And let's get rid of this. And let's say I have an array with a couple of items in, 1, 9, and 2. And I want to add another one. I said I'm adding to the end. What's one of the things that I'm going to need for this guy? So if I'm working with creating a class called stack, stack is going to import my list.h that was for an array, which has the functions is empty, is full, display, a couple of those things already done for me. What would I need as far as maybe a variable to go along with this guy? Some sort of count? Whew. It's a rough day out here today, folks. I'm going to need some sort of count, because if my count right now is 3, where would I add the next item?
At the end.
At the end, but what location would I add the next item?
4.
Well, I'd add it at 3, wouldn't I? Because this is 0, 1, 2. So right now count is 3. If I add an item, I'm going to add it at 3 and increment count kind of idea. So I think something really important in array is count to adding to the end. If I come back over here, Matthew said, my choices are head now gets a value of 11, which now goes to 5, which goes to null, or I can add here at 5, and when I add the 11, I'm going to add it to the end. Okay. So let's talk about this a little bit. I'm trying to cover up. Here, let me move it up a little bit. Let's talk about, so if I wanted to add 11 to the front, looks like head would point, head's pointer would get new node's pointer would get the value of head. Head would get the value of new node. That's kind of easy. How would I add to the end? Well, I'd have to traverse all the way through to get to the end to add it, or I'd need a separate pointer to tell me where the end is. Let me review that. This first one, if I want to insert, I would say new node's pointer gets the value of head. Head gets the value of new node. If I wanted to add to the end, I would either need to traverse through until this pointer equals null, which could go for quite a while, or I'd have to have a whole separate temporary pointer to point to the end. So to add to this stack, which one's easier? A or B? A or B? Everybody has to change their name to either A or B, so I can see what you're picking. Is it A, inserting in the beginning, or B, inserting in the end?
How do you change your name?
Peter,
Yeah, how do you change your name?
if you go up in the upper right-hand corner, is there a little of your picture? So where your
Yeah.
picture is there an ellipse, a dot, dot, dot?
Yeah,
Is it ellipse or eclipse? What's the name of that dot, dot,
I think
dot?
it's the.
I think it's the ellipse,
Yeah.
but I can't see an option to change my name.
It's not up there?
No.
How about if you go
Nope.
down, do you have something that says participants
Yeah.
down along the bottom? Can you rename yourself there?
We can just type it in chat.
You could just retype it in chat. I'm trying to wake y'all up in case you haven't figured this out yet. I'm not
Yeah.
getting much feedback.
It doesn't appear that we can change our
All right,
names.
so Brady is overwhelmingly telling me it's A. Ken says it's A. I think inserting to the beginning is going to Anna, Kevin. Everybody is coming at me with A's. Nobody needs to be contrary. I'm waiting for somebody to type in abstain. Because I love when people abstain. Yeah, that's not even spelled right, but thanks, CJ. Okay, so from what I see, yeah, present. From what I see and what you folks are telling me, I'm now going back to my speaker view, that to insert in the beginning is going to be easier. What about deleting? How would I delete? Well, if this guy, I get ready and I'm going to pop, and I'm popping from the front, which was my first example, all I would have to do is say head gets the value of head's pointer and done. What if I wanted to delete here? I'd have to go all the way to the end, but I'd have to get back to here somehow. So this guy can put, so I almost think I would need two pointers. So I think you just got outvoted, Matthew. I think it's going to be easier to add to the end. Or excuse me, add to the beginning, pop from the beginning. My array was add to the end, pop from the end. All right, here we go. Under the array, we're going to need a pop and a push. Push it real good. Over here, we're going to need a pop and we're going to need a push. I would like algorithms for all of you that go to breakout room number 1. An algorithm for pop and push for a static array. For the static array. Everybody going to breakout room 2. I want you to work on algorithms for pop and push using a linked list. After about 15 or 20 minutes, you're gonna come back and we're gonna report out to the other group. Cause I'm tired of talking. So I gave you the overall concepts. I drew some pictures to make things make sense. You may still have to draw some pictures. I think programming wise, the array one might be easier. So anybody stuck in group 2, you're gonna have your work cut out a little bit to do that. Group 1 is arrays, group 2 is linked lists. Okay, who's gonna report out for the array group? I think it was Matthew's screen, right?
I'll share my screen, but somebody else talk.
That sounds good.
Okay, so we have an array of 1024 because that's a cool number, and I didn't really know what else to make it. So size is actually should be called num items. So num items, just pretend size says num items, is the number of items that we have in the array that we have declared. So array is just an empty array of random integers. So since we only need the values that we declare, that's what size is for, or I mean num items. So push is going to take an integer, which we just have called value, and we're going to set the last item that we have declared equal to that value, and then we're going to increment num items by 1. And then for pop, we're going to decrement. We're going to remove 1 from num items, and then we're going to return what number we just removed. I don't know why, but he told us to do that. It was for some future information that we haven't learned yet. And for our test data, num items is declared at 0. It should be declared at 0 like in the program, but it's not really a program. And then we push 5, 9, and 1. And then we pop it, so we only have 5 and 9 at the very end.
Okay, so down in pop, I have size is 4. There's 4 items, okay? In 0, 1, 2, and 3. So there's 4 items, size is 4. And if I say decrement that, size now becomes 3, and you want to return array sub 4?
You're right, that's wrong.
Okay. I wanted to make sure you guys went through that with the test data.
Wait. So we're on return array size plus 1. Is that what we're talking about?
So I
Yeah.
think we can just do decrease size by 1 and then just return array of size. So I would say take that part off.
All right, so I need to go, and I'm just getting this straight in my head. So if I have the array with the numbers 2, 4, 6, and 8, okay? And I'm thinking 0, 1, 2, and 3. So size is 4. I get ready and I decrement size to 3, and I want to return array sub 3, which is the 4th item, okay? So again, this is where it's going to become really important to have that size, because you may have other items past what you're working with. We're not bothering to go and remake those into numbers like -5 or some irrelevant number that down the road we will. When we remove something, if it's empty, right now, if it's empty, what's in it? Zeros maybe? I don't know. Could zeros be numbers you're pushing? Yeah. Down the road, we're going to need to really make sure we keep track in the array of how many items there are, because there's going to be other stuff in the memory that we may not want. Okay, so hopefully group 2 got an understanding of what's going on. They're sitting there saying, boy, you got away with something pretty easy. All right, Matthew, thank you. Thank you. Stop sharing, start sharing other group. So Matthew, you didn't have to save that when you did share screen. It's stuck up there, right?
No, I had to share it, or I
Save
thought
it.
I ended up saving that. I don't think, nope, you're right. My whiteboard still had it.
Okay. Go ahead, other group. They had the question whether to save it or not. The big takeaway today is supposed to be stacks. I think the big takeaway today is the whiteboard option. All right, let's see what they have. So they have something for push. Go ahead, take it away.
Yeah, I guess I can talk real quick.
Uh,
For like, we checked if like the head is empty, and if it is, then you just create your new node. But then we brought it down, and I put my like little else over there because I'm not sure if it'd work or not. But I'd create like a pointer value to hold that original head, and then I'd set a head to a new node, and I'd point to that new node to like bring it back to that head, so you already delete that first value in that. If that makes sense.
Okay, so I see you have, if head is empty, head goes to new node. That's fine.
Yeah.
Because
Yeah.
new node should already point to null.
Yeah.
Else, you
Well,
have,
not yeah.
you have
I'm
two
not sure
different,
about that.
you have two different else's.
Yeah. Well, we're just trying to like figure stuff out.
Okay. On the second one, you say node pointer equals head.
Yeah.
I think, should that be, your nodes next kind of deal, or new nodes next?
Should it
Or
be?
did you add another pointer in there and so on and so on? I'm thinking it may be these two lines should go in there. New nodes next gets the value of head,
All right.
head gets the value of new node.
Okay.
Does that make sense?
Yes.
I'll say it again. The new nodes next gets the value of head. Head gets the value of new node. Okay. Good. Thanks, everybody.